Alright, so today I want to talk about finding the leading coefficient and the constant term while your polynomial is completely factored out in a factored form. This is a nice shortcut if you're asked on the SAT or something like that about the function's end behavior, or even if you need to find like the leading coefficient and the degree. This is a nice easy way to get it without doing a whole lot of work. I'm going to also talk about sort of why it works. I don't want to just give a shortcut without the reasoning why, but I hope it helps. So let's jump into it. So if we were to be given a polynomial in factored form, say 2x minus 1 times x plus 3 times 4x minus 5 times, I don't know, x plus 2. That's good. It would be so much work to put this factored polynomial into standard form without using some sort of website or a graphing calculator. If you're on like an SAT or ACT problem and they want the degree or the leading coefficient or the constant term, or for you to use those things to determine the function's end behavior, it would be a lot of work. So instead, we're going to find the leading coefficient and the constant term just by using what we know what happens when we multiply polynomials together. When I multiply a factored polynomial together, what ends up happening is that I got to distribute the 2x to the x and then to the 3. And then I got to distribute the -1 to the x and the 3. And then that gives me some 3-term polynomial, possibly a 4-term polynomial. And then I got to multiply it by the next piece, the 4x minus 5. And now your leading coefficient and your degree of this polynomial comes from multiplying these two things together. The 2x and the x gives you 2x squared in this case, and that's going to end up in the front of that next polynomial. And then the new leading coefficient and degree is going to end up in front again when I multiply these two things together and end up with a new 4-term polynomial, say a, b, c, and d. The spot in this a position is going to come from multiplying a by 4x, and that's going to go right there in front. And so basically, in order to create the leading coefficient or the degree of the polynomial, that term comes from multiplying all of the leading coefficients and all of the degree terms together, but we're doing all of the extra work of finding out what -1 is times the x and -1 times the other stuff, and doing all of the other terms inside of that work. So the shortcut, I'm going to have to hit this undo button quite a bit to get back there. The shortcut is knowing that your leading coefficient and your degree are going to come from all of those first terms. So the shortcut is just to simply multiply those things together. So in this case, taking 2x and multiplying it by x, and then multiplying it by 4x, and then multiplying it by x again. So if I multiply those 4 things together, I multiply all of the leading coefficients and, well, the leading terms, I guess, in each of the smaller polynomials. As long as I multiply those together, I will get the leading coefficient and the degree of the big overall polynomial that would come from this multiplication. So 2x times x times 4x times x gives me 8x's to the 4th. And now if you sort of understand that the leading coefficient and the degree of the polynomial are going to come from all of the leading terms, then hopefully you understand and can see that the constant term is going to come from multiplying all of the constant terms of each little factor together as well. So we're going to multiply -1 by 3, and then -5, and then 2. We're going to do all of those multiplications together to get the constant term. So -1 times 3 times -5 times +2 is going to give us the degree of, or not the degree, it's going to give us the constant term of this polynomial. So -1 times 3 is -3 times -5 is a +15 times 2 is a +30. And there you have it. You have the constant term of that polynomial. Another way that this can be effective on the SAT or ACT is if they ask you to find the standard form of a big, long, factored polynomial. You can do these two tricks first and pretty quickly to find the leading coefficient and the degree and the constant term to like whittle down your choices. And with any luck, because you're given 4 choices, I'm sure 2 of the choices are going to have 8x to the 4th, and then another 2 are going to be like +30 or -30. You're going to be able to limit your choices down pretty quickly, and it's just a simple trick of finding the leading coefficient and the constant term right from the beginning. So I'm also going to factor into this what happens when we put a number out in front. So if we put like a 7 out in front, that's going to change everything because now I've got to use that number in those calculations. So we're going to do a quick example of what that'll look like right now. So let's say that I have a -2 times 3x plus 1 times x minus 2 times 4x plus 3, let's say. So what we're going to do, the new thing is this number out in front, and that number out in front is going to get included into both finding the leading coefficient and the constant degree. And if you're wondering why I would include it in both when I didn't use all of the x terms or any of the x terms in finding the constant term, and I didn't use any of the numbers, any of the constant terms and the factors when I'm finding the leading coefficient, and that's because once I multiply all of these pieces together, I'm going to get some big long polynomial that I'm going to use letters for. A plus B plus C plus D plus E. So I get some big long polynomial, and at the very end of it, I would have to multiply by that -2. And I would distribute that -2 to all of the pieces inside the polynomial, all of the terms, including the leading coefficient and the degree of the polynomial, and also the constant term. So when I'm finding the leading coefficient and the constant term from this polynomial with that number in front, I'm going to multiply it by both of them. So let's take a look at what that'll look like right now after I delete all of this. So get all this out of here. So step 1, I want to find the leading coefficient. So I want to take all of the leading terms of each little factor and the number out in front. So I'm going to do -2, the number out in front, times 3x times x times 4x. And so -2 times 3x is -6x, times x is -6x squared, times 4x is going to give me -24. 6 times 4 is -24. Well, -6 times 4 is -24. And then that x squared times x is going to give me x cubed. So that's the leading term of my polynomial, the leading coefficient, and then shows me the degree of that polynomial. Next, I'm going to move on to the constant term. Same thing as before, I'm going to multiply all of the numbers together, all the little constant terms of my factors, and I'm going to include that number out in front. So it's going to be negative 2 times 1 times the negative 2 of my second factor times that positive 3 of that last factor. Negative 2 times 1 is negative 2. So then I've got to do negative 2 times negative 2, which is a positive 4. And then positive 4 times 3 gives me 12. And so then that's the constant term. Hopefully this video helps you find the leading coefficient or the degree or the constant term pretty easily from a factored form polynomial. It also should help you on any kind of standardized test question where you got to figure out what the standard form of the polynomial is when they give it to you in factored form relatively quickly. You could do this trick even just to check if it'll help without doing a whole lot of work and finding a bunch of extra terms that you might not need to. Because on the SAT or ACT, it's all about speed and giving yourself plenty of time for those more tricky questions and not spending a lot of time on the more simple questions. So all about using your time wisely. I hope this helps. If you've got questions, leave them down below. I'd love to be able to answer any questions you guys have, and you will see me next time. Bye.